Hi everyone, so this is our first video in the coordinate geometry unit. So we're going to start with a little bit of review on coordinate geometry. So you always want to use a ruler when you are graphing, as evidenced by my not exactly perfectly straight lines. So when you are talking about coordinate geometry, we're referring to Cartesian plane. So Cartesian plane is two lines referred to as the y-axis, the vertical, and the x-axis, horizontal. So those two axes divide up two-dimensional space into four quadrants. So we've got quadrant 1 here, where both x and y coordinates are positive, 2, 3, and 4. So we've divided up our space, two-dimensional space, into four sections, four quadrants. So in so doing, we can place a point somewhere here, and we can give an explanation, give a location for that point in two-dimensional space using two numbers, an x coordinate and a y coordinate. So from the center point of our axes, referred to as the origin, where the coordinates of the origin are 0, 0, we will count horizontally to determine what the x coordinate is of that point. So we would count 1, 2, 3, 4, 5, 6. So our x coordinate is going to be 6. And then our y coordinate, we count vertically, 1, 2, 3, 4. So the coordinates of that point are 6, 4. So again, x and y axes act like number lines. So if we're moving to the right on the x-axis, we're going to be positive. If we're moving to the left, we're going to be negative. On the y, if we're moving up, we're going to be positive. And if we're moving down, we're going to be negative. Okay, so that should all be review for you, hopefully. If it's not, you might want to spend some time sort of finding some places to get a little bit of review on. So today we're going to do the first formula for this unit. So the first formula has to do with finding the distance between 2 points. So what it is that we're doing today is we have 2 points in this two-dimensional space, and we're going to find the distance between them. That's it. So if those 2 points are aligned sort of vertically, that's pretty easy. You just count from where you are, 1, 2. So these are 3 units apart from one another. Similarly, if they are in the same horizontal plane, that's also really easy. Again, you just count 1, 2, 3. So these are 4 units apart from one another. Great, that's easy. The problem is when they are not in the same plane. So if we have one point here and we have another point there, all of a sudden that's not as easy to calculate, right? So we're figuring out what is this distance, and we don't want to use a ruler because the units, it's not really the same kind of thing with measurement in that respect. So what we're essentially going to do is we're going to turn this into a bit of a right angle triangle. And we're going to figure out how far what is the horizontal step, and then what is the vertical step. And the formula essentially takes Pythagoras, right? So we've created a right angle triangle here. It takes the vertical step, the horizontal step, squares both, and then finds the square root of it to figure out what is this distance there. And the brilliance of the formula is you don't have to graph all of these every single time. You don't have to graph them at all. So let's take a look at the formula. So we have 2 points. Point 1 is going to be x1, y1. Point 2 will be x2, y2. So when you know the coordinates of your 2 points, you just arbitrarily assign 1 to be point 1, and therefore the coordinates of that point will be x1, y1. And the other one will be point 2, so the coordinates of that point will be x2, y2. And then you just plug those values into the equation that you're given, that you can see here, and that's how you figure out the distance between them. So it looks really ugly, but you can see elements of Pythagoras here. We've got the horizontal step, x2 minus x1 squared, plus the y step, y2 minus y1 squared, and the square root of all of that. So you can see where this comes from. And then this one is just sort of kind of a more generalized version. So let's walk our way through a couple of examples of how we can use this formula. And yeah, then we'll go from there. Okay, so our first example here, find the distance between A and B. So A is -2, 1, and B is 3, 4. So arbitrarily, I am going to say that that is point 1. So that will be x1, y1. And then B will be my point 2. So x2, y2. Okay, so then off we go with the formula. So AB is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. So now we're just going to plug our values right into the formula. So we've got x2 is 3 minus -2, square that, plus 4 minus 1, square that. So if you are comfortable with using your graphing calculator, you could put that entire bit into your calculator and away you go. You can also work it out a piece at a time, sort of more by hand method, which is also fine. Okay, so we've got 3 minus -2, so that becomes 3 plus 2. So that's 5 squared plus, and then 4 minus 1 gives me 3 squared. So AB is equal to the square root 5 squared. We've got 25 plus 9. So AB is equal to root 34. So thinking back to our radicals and surds unit, we're going to want to put that in simplest radical form. There's almost no need to go to a decimal on this. Actually, there really isn't a need, so don't do that. So if you were to take this step up here and plug that into your calculator, I probably wouldn't do the square root sign. I would just do what's underneath the square root here, because otherwise your calculator will give you a decimal. If you just put in what's underneath the square root, then you would sort of jump down here and you would have this number from your calculator, and then you just have to remember to put that square root back over it. So that's the basic use of the formula. Here's 2 points, find a distance. Great, plug it into the formula, away you go. So the formula has some other uses, more like a test. And so it has to do with testing triangles. And there's 2 kinds of questions that you're going to see. The first one is like this, where it asks you to determine what kind of triangle it is. So in order to do that, you need to know that an equilateral triangle has all sides the same, an isosceles triangle has 2 sides the same, and a scalene triangle has no sides the same. So in order to figure this out, you need to figure out the length of all 3 sides of your triangle, and then if all of them are the same, you got an equilateral. If only 2 of them are the same, you've got isosceles, and if none of them are the same, you have scalene. So let's, sometimes I find it helpful just to kind of sketch out my triangle, just to kind of remind myself what I'm doing. So I need to figure out side AB, I need to figure out side BC, and I need to figure out side AC. So I'm going to have to use this formula 3 separate times. So let's get started. So when I'm doing AB, I've got -2, 0, and I've got 2, 1. Those are the 2 points that I'm going to use. So I'm going to say that that's x1, y1, x2, y2. And then I can head straight to my formula. So AB equals x2 minus x1 squared plus y2 minus y1 squared. So AB equals, what do we have here? 2 minus -2 squared plus 1 minus 0 squared. 2 minus -2 is 2 plus 2, so that's 4 squared. 1 minus 0, that's 1 squared. That looks like 12. 1 squared. So AB equals 16 plus 1. So AB is equal to root 17. So there's side 1 done. Now we're going to go to BC. So BC is going to be using coordinates 2, 1, and 1, negative 3. So B and C this time. So again, x1, y1, x2, y2. And then away I go with the formula. So I've got BC equals. This is tedious work. I fully admit that. But I don't know that it's necessarily difficult. Formula work is not generally difficult. If you can plug your values into the correct places, you're generally going to get the correct answers. So making sure that you have your x1, y1 carefully labeled is, that's the biggest thing, which I just did incorrectly. Okay, so let's try that again. 1 minus 2 squared plus negative 3 minus 1 squared. That'll teach me to talk while I'm trying to write at the same time. Okay, so 1 minus 2, negative 1 squared. Notice I'm putting the negative in brackets to remind myself that that negative also has to get squared. And then I have negative 3 minus 1, so negative 4 squared. So BC equals negative 1 squared is 1, negative 4 squared is 16. So BC is equal to root 16. So all of a sudden, right off the bat, I see that AB and BC are the same. So this is at least isosceles. So now we have to do AC to see if it's isosceles or if it's equilateral. So AC means we're using negative 2, 0, and 1, negative 3. So again, x1, y1, x2, y2. So AC equal to x2 minus x1 squared, y2 minus y1 squared. So AC equals, so 1 minus negative 2 squared plus negative 3 minus 0 squared. So AC equals 1 minus negative 2, 1 plus 2. So 3 squared plus negative 3 minus 0, so negative 3 squared. So AC is equal to 9 plus 9. So AC is equal to root 18. So I get that root 18 can be simplified, but for the purpose of this question, I just need to know if the sides are the same or not. So I'm not going to worry too much about simplifying that one. So I see that I have 2 equal sides and one that's not the same as the others. So then this would be an isosceles triangle because 2 sides are the same. So that's one of the ways that you can use this distance formula as a test. The other one is to determine if you have a right angle triangle. And I'm not going to do an example of that one, but I might just kind of run through how you would do that. So if you have 3 coordinates and you're asked, are they right angles? So then let's imagine that A is 1, 2, and B is 2, 5, and C is 4, 1. So if this is a right angle triangle, then Pythagoras should work. So what you need to do, again, thinking that this is a triangle, you need to find the distance between AB. You need to find the distance between BC, and you need to find the distance between AC. So you need to find the 3 sides of your triangle. Then you would have to plug those sides into your formula and see if it actually works, ensuring, of course, that you get your longest side there. And then if those 3 sides work with Pythagoras, then you do have a right angle triangle. And if they don't work with Pythagoras, then you don't have a right angle triangle. So I'm not going to go through a whole process on that. The process is very similar to the triangle question that we did, where you have to find the 3 side lengths, but then what you do with them is just a little different. With this question that we did out together, what you do with them is just look at them at the end, see if they're all the same or 2 the same or they're all different. With the right angle question, once you have your side lengths, you still would have to do Pythagoras to determine whether or not this is actually a right angle triangle. So the last example that I want to go through is, what do you do when you're asked to find a bit in the middle of the equation? So using the formula, but you already know the answer, as it were, to the formula, but you're solving for part of it. So you know that these 2 points are root 13 units apart. So now you have to figure out, what's this missing piece? So start the same as you would normally. Identify one of them as point 1, so x1, y1, and then x2, y2. And then you're going to start the same way with your formula. So we've got x2 minus x1 squared plus y2 minus y1 squared. So we're going to insert everything we know, and then for the one thing that we don't know, we're going to replace it with this lowercase b. So we know the distance is root 13, so we're going to start there. We know that x2 is b, x1 is 3 squared, plus, and we know y2 is 1 minus y1 negative 2 squared. Okay, so now you're just solving an equation. So the first thing I might do here is I might square both sides, because by squaring both sides I get rid of that square root sign, and that's just going to make it a little bit neater and tidier. Same time I do that, I'm going to start to kind of simplify over on this side a little bit. So I can do 1 minus negative 2 is 1 plus 2. So now I've got this. So then I'm going to simplify a little bit more. Some of you might be tempted to FOIL that. I would not go down that path. Now I'm going to subtract 9 from both sides. So I've got 4 equals b minus 3 squared. So at this point I want to get rid of that squared. So now I'm going to square root both sides. And this is where things are gonna get interesting. So when you take the square root of something, you could have a positive or you could have a negative. So now this question splits into 2, because b minus 3 might equal positive 2, or b minus 3 might equal negative 2. So I kind of have to run with both, because I'm not given any sort of indication about whether one could be discounted or eliminated or anything. So I just have to proceed with both possible options. So we end up with 2 possible answers. B is equal to 5 or 1. Okay, so to recap, formula number 1 is finding the distance between 2 points using the vertical step and the horizontal step and Pythagoras. So the formula, which you will always be given, you don't need to memorize, although you might inadvertently memorize it anyway, is given here. AB, distance between A and B, is equal to the square root, x2 minus x1 squared, y2 minus y1 squared, add them together. So we've got one example of just using the formula in sort of the most basic way. Then we talked about 2 tests that this formula can help with, testing what kind of a triangle we have, or testing whether or not something is a right angle triangle. We didn't do that equation or that example entirely, but if you look at example 3 in your textbook, it walks you through that. And then we looked at how do you use the equation if you know the distance but you're missing one of the points, and we walked through that one. Okay, so that about does it.